Welcome to 8.5 for hyperbolas. We're going to write equations and graph equations of hyperbolas. So let's start with what a hyperbola comes from, the conic section. If you draw a plane straight down through the cones, the double cones, then you create hyperbolas. Hyperbola is a set of all points in a plane such that the absolute value of the difference of the distances from two fixed points called foci is constant. Standard form for hyperbola is x squared over a squared plus y squared over b squared equals 1. Where 2a equals the length of the transverse axis, and 2b is the length of the conjugate axis. Alright, so let's see a little bit about the hyperbolas. So, similar to an ellipse, except this time it's minus instead of plus. Same thing happens if x is with a, it's horizontal. If y is with a, it's vertical. Foci is still c0 and negative c0, except this time c squared equals a squared plus b squared. Length of the transverse axis is 2a, and length of the conjugate axis is 2b still. The equations of the asymptotes is, so this is a new part, equations of asymptotes is y equals plus or minus b over a times x. Alright. So example 1, we're going to write an equation for a graph. So here we have our vertices. They're 0, 3 and 0, negative 3. Therefore, a equals 3. Our foci are 0, 4 and 0, negative 4. Therefore, c equals 4. And our center is at 0, 0 because it's halfway through between our vertices, halfway between our foci. So we got a and c. So we're going to do c squared equals a squared plus b squared. So 4 squared equals 9 squared. 3 squared plus 8b squared. 3 squared is 9. 4 squared is 16. 16 minus 9 gives us 7. So b equals the square root of 7. It is vertical. So therefore y is with a. You need to keep that in mind when we write the equation. So it's going to be y squared over a squared. So y squared over 3 squared minus x squared over the square root of 7 squared. That equals 1. We're going to square the denominator, so it's y squared over 9 minus x squared over 7 equals 1. So that's the equation of our hyperbola. Alright, our next example, the Lorentz navigational system, is based on hyperbolas. Two stations send out signals at the same time. The ship notes the difference in the times at which it receives the signals. The ship is on a hyperbola with the stations as foci. Suppose a ship determines that the differences of its distances from the two stations is 50 nautical miles. The stations are 100 nautical miles apart. Write an equation for hyperbola on which the ship lies if the stations are at negative 50, 0 and 50, 0. First, we're going to draw a figure. So we got the 50 and negative 50 as our foci. And by studying either the x-intercepts, you can see the difference of the distances from any point on the hyperbola to the stations at the foci is the same as the length of the transverse axis, or 2a. Therefore, 2a equals 50, so a equals 25. Okay, then the foci are at 50, so c is 50. We're going to do c squared equals a squared plus b squared. So 50 squared equals 25 squared plus b squared. B squared equals 1,875. So b equals the square root of 1,875. Since the transverse axis is horizontal, the equation is in the form x squared over a squared. So it becomes x squared over 25 squared minus y squared over the square root of 1,875 squared equals 1. So when we square that, we get x squared over 625 minus y squared over 1,875, again equal to 1. So again, we can translate this with the minus h and minus k, where hk is our new center. Still horizontal if x is with a, still vertical if y is with a. Our asymptotes this time change a little bit, so it's y minus k equals plus or minus b over a times x, the quantity x minus h. And so if it's vertical, we just flip the a and b. So instead of b over a, it becomes a over b. So our example 3, we're going to graph hyperbola in standard form. So find the coordinates of the vertices and the foci, and the equations of the asymptotes for the hyperbola with equation x squared over 9 minus y squared over 4 equals 1. We're going to graph the hyperbola. So first thing, the center of the hyperbola is at the origin because we don't have h or k. According to the equation, a squared equals 9, b squared equals 4, a equals 3, and b equals 2. So because of that, our center is 0, 0, a equals 3, b equals 2. We can find our foci by doing c squared equals a squared plus b squared, so 3 squared plus 2 squared equals the square root of 13. Our vertices are 3, 0, negative 3, 0 because of our a. And then we have our foci, which is 0 plus and minus the square root of 13, comma 0. And then the equations of our asymptote, since it is since a is with x, then it's horizontal, so it's b over a times x, plus or minus. So b over a is 2/3. And then we're going to use the calculator to find some approximate non-negative values for x and y that satisfy the equation. And then we graph the hyperbola. Here's what we get. So notice we got the two asymptotes that kind of create where the hyperbola sits, and then you got the two axes, the transverse and the conjugate axes, that kind of create the box in between. Last example, we're going to graph hyperbola in non-standard form. So we're going to group the x's together, group the y's together, and complete the square, and then subtract 19 from both sides. Since we factored out a 4 and we factored out a 9, we can't forget about that when completing the square. So negative 8 divided by 2 squared is 64 times 4. And we'll add that to both sides. And then 2 divided by 2 is 1, squared is 1, times negative 9, so we'll subtract 9 from both sides. So add 64, subtract 9, left we get x minus 4 squared times 4, minus 9 times the quantity y plus 1 squared equals 36. And so our then we divide by 36 to get it equal to 1. 4 over 36 becomes 1/9. 9 over 36 becomes 1/4. So we get our equation as x minus 4 quantity squared over 9 minus y plus 1 quantity squared over 4 equal to 1. Here we know our center is 4, negative 1. Our vertices are at, our a is 3, so 3 plus 4, negative 3 plus 4, and then our b is 2. So our vertices are 7, negative 1, 1, negative 1. C squared equals 3 squared plus 2 squared, so to find our c is square root of 13. To find our foci, we get 4 plus the square root of 13, comma negative 1, and then 4 minus the square root of 13, comma negative 1, because that's where our h is. And then our asymptotes are y plus 1 equals plus or minus 3 over 2 times the quantity x minus 4. And then we graph our hyperbola. So we got our asymptotes that cut through, and then our transverse and conjugate axis with length of 3 and 2. Okay. So good luck on the practice.